This lecture is on estimation and sampling. You must be, by the end of this lecture, be able to understand questions to do with confidence interval and calculating a sample size. To start with, estimation has key terms we're going to look at. What an estimate is, what a parameter is, and we're going to look at characteristics of a good estimator. An estimator, by definition, is simply a statistic whose calculated value is used to estimate a population parameter. And an estimate is a particular realization of an estimator. So we have what we call a point estimate, an interval estimate. A point estimate is simply a singular number that is calculated, whereas an interval estimate is within a confidence interval. So properties of good estimators are: one, they must be consistent; two, they must be unbiased; three, they must be precise, etc. and etc. So now we need to understand the following table. What we call confidence level, significance level, alpha value, and our Z alpha value. So we have the common 99%, 98%, 95%, and 90%. The difference from 100 is called the level of significance. So 99 from 100 is 1%. 98, we have 2%. The alpha is when you divide it by 100, this is 0.01. When you divide 2% by 100, this is 0.02. Everything means the same. So help me finish up the last two. What is the significance level at those 2 points?
It's 5%.
5%. At 95%, then what is our alpha?
0.25.
0.05. Then at 90%, what is our
10%.
is 10%? Then what is our alpha?
0.10.
0.10. Now, this is a critical table that I need you to learn how to calculate. So I'll start with 95%. Step one, find the level of significance. For 95%, I want to know the Z. This is 5%. Then since it's a two-tailed alpha over 2, we divide our significance level by half, or by 2, it's a two-tailed test. If it was one-tailed test, divide by 1, it's 2.5. Then we subtract the answer from 100. We get 97.5%. Then we convert to decimal, 0.975. And you read from inside the table the Z score. When you go into this table here, read from inside the table. So So you know how to read the Z tables by now. 1.23 or 1.22 is 0.888. 0.88 is a probability. When you're going backwards, this is called 1.22. That is our Z. So here inside, we're going to look for 0.975. 0.975 is here. If you don't find the exact figure, you find what is closer. So what is a Z at 0.975? Somebody? What is a Z at 0.975?
1.96.
1.96, correct. So this is where the 1.96 comes from. Okay, together, let's see the Z for 99%. Step 1, the significance level is 1%. Step 2, half of the significance level, which is 0.5. Step 3,
We subtract from 100.
is 99.5. Step 4, convert to decimal, which is 0.995. Then check from inside the table. If we don't find the exact, we find the closest possible. What do we get? We're looking for
I've seen 0.9955.
0.9950. What are we getting? 0.9955. If you don't find the exact one, you find the closest possible.
There's 0.5955 and 0.9.
So these two are
53.
closest. More than by 1 and less by 1. So the actual value is 0.578. So 575. You can choose any one of them. Okay. So meaning the Z is 2.575. 58 if you want. This one, when you do the processes, we find at 2.33. This one, when you do the processes, we find at 1.645. You need to know the process. Sometimes you'll be given maybe 80% or 97%, at least you know the process. Under estimation, the formulas you need to know. Confidence interval is equal to mean plus or minus Z standard deviation over square root of n. Z is only used when samples are greater than 30. Confidence interval can be given by P plus or minus Z PQ over N, capital N. Confidence interval has two intervals. You have the lower bound, then you go to the upper bound. Don't start with the upper bound. Using the lower bound, when you add the lower bound, the upper bound, and you divide by 2, you can get what is called a mean. But when you subtract the lower bound minus the upper bound, divide by 2, you get what we call the error. Then you can also find a sample size. For the sample population using Z. You can also find the population using the P. Population size. Error comes with terms within, the word within. Okay, so before I go to exam type questions, find the missing. Find the missing. So suppose we are asked to find the confidence interval don't know, but the mean we are told is 10. Our alpha is 0.05. The standard deviation is 12. The n is 36. You can also be asked to find the confidence interval when your p is 10%, your level of significance is 1%, your n is 50. Sometimes you can be asked to find the sample size n when your confidence level is 10% and your error is 2. So let's try to find these given the formulas. Confidence interval is a range. So question number A, we're given what? Our mean as 10, our alpha as 0.05, and our n as 36, and our standard deviation as 12. The formula for confidence interval is equal to what? X bar plus Z standard deviation over square root of n. So our X bar here is what? 10. Our Z from the 5% here, our Z is what? 1.96. We need to master that sum. 1% is 99%, which is 2.58. 2%, can somebody remind me? The same as what? 98% or 0.02, which is 2.33. Help me with the last two, 5% and 10%. What is a Z?
5% is 1.96.
And 10%?
1.645.
So we are at 5%. Our Z is what? 1.96. And our standard deviation is what? 12. And our n is 36. So here we're going to have 10 plus or minus 1.96. 6 into 12, 2. So when you multiply this, we get what? 3.92. We start first by subtracting 10 minus that. What do we get? 6.08. When we add, we get 13.92. Then you comment in terms of the confidence level that we are. What percentage? 95% confident that the true mean will lie between 6.08 and 13.92. Okay. It's not mandatory that you can comment, but that is what we call the confidence interval. The next question, we're given our P as 10%, and our confidence level as 10%, our N as 50. If P is 20%, then the Q should be what? The opposite, 90% or 0.9. So confidence interval for proportions is given by P plus minus Z PQ over capital N. So our P is 10%, which is 0.10. Our Z from 90%, or from 10% is 1.645. So here we have 0.1 times 0.9 over N, which is 50. So can somebody calculate what is in the square root there quickly? What are we getting? Don't forget to square root it.
We have 0.0424.
4. And you multiply that, what are you getting?
We have 0.0697. 0.069.
So this is the same as 10% plus minus 6.9%. So when you subtract, what are you getting? (3.1%, 16.9%. So we are 90% confident that the true proportion, not mean this time, is between 3.1% and 16.9%. Sometimes you'll be given a range. So we are told to find the sample size when our confidence level what? 10% and standard deviation 5 and error 2. 10%, standard deviation is 5 and our error is 2. The weight that comes in terms of error is the weight within. Sometimes you may not find error itself, you find the weight within. So how do you find the sample size? N is equal to Z squared variance over what? Error squared. So can somebody tell me what is our Z? 1.645. And what is our variance of standard deviation? 5 squared. And that's our error squared. What do we get? What do we get?
We have 16.91.
16.91. So that is our sample size. So sometimes we'll be given 10, 20. Our sample size is already given as 100, and our alpha as a 0.02. Then you're asked to find the mean, the error, and the standard deviation. So if you're given a confidence interval, we know that mean is equal to the lower bound plus what? Upper bound divided by 2. So our lower bound is 10, our upper bound is 20, divided by 2. So this 30 divided by 2, what we get? 15. And our error is the difference, lower bound minus upper bound divided by 2. 10 minus 20 over 2. The error is plus minus. You can get a negative or a positive. 10 minus 20 is negative 10 divided by 2. It's plus minus 5. So the mean is simply when you add these two and divide by what? 2, which is 15. The difference between this and that is called your error. So there's a difference of plus minus what? 5. From 15 to 20 and from 10 to 15. So now you are asked to calculate the standard deviation. So we know that sample size is given by the following formula. So our n has been given as 100. Our z from 0.02, who can tell me what is our z from 0.02?
It's 233.
2.33. Our variance, our standard deviation is what we're looking for. And our error was found as 5. So we can cross multiply. So this by that, 5 squared. 5 squared times 100, that is 2500. 2.33 squared over variance. So we divide both sides by 2.33 squared. Please calculate for me our variance. And remember to square root it to get our standard deviation. So what becomes our variance? That note,
It is 460.
460.49.
49.
Okay, that is the variance. 460.49. So what becomes our standard deviation when you square root it?
And 1.45.
21.45.
45.
You all agree? Okay. So we now go to an exam question. Now I need you to follow closely. Those that got this pamphlet, page 58. So I want us to participate completely. Okay, let me broadcast this. An exam type question. On the basis of results obtained from a random sample of 100 women from Porokoso district, 95% confidence interval for the mean height of women is found to be 77.22, 177.22, and 179.18. Find the value of the mean. Calculate a 98% confidence interval. So what are we given in this question?
I've been given a sample.
Good. I need all of you to participate. So we're given the sample. What's the sample? We're given n. Our n is what?
100.
100. What else are we given?
Our confidence interval.
Confidence interval, which is what?
Which is 0.5.
The interval is the range.
Oh.
122 and 190, 179, 18. What else are you given? What else are you given? Confidence level is what?
95.
Therefore, what is our Z?
Our Z is 1.96.
1.96. Really need us to get or master this song before I go any further. Everyone, quickly. We have confidence interval, significance level, alpha, and our Z. Okay, I will start. 99, we have 98, we have 95 and 90. Now the ladies only. Give me the levels of significance. Here what we have, ladies. Here. Ladies, what's our level of significance here quickly? Do you have any ladies? Yes, Daphne?
Yes, but
Maggie, yeah?
I'm lost. I don't even know what that is.
The confidence level here. This is the first thing you need to know. Confidence level, 99%. The difference from 100 should be the significance level. What do we have here? 1%. Yes, Maggie, here?
2%.
Then?
5%.
5%.
Then?
10%.
10%.
When you divide this by 100, the name is called alpha. So what is our alpha here?
Zero point 0.01.
0.01. Here?
0.02.
0.02. Here?
0.05.
And finally?
And 0.1.
0.1.
0.1.
Okay, the ladies will give me the upper two, the gents will give me the down two. I'll start with the gents. Here?
1.96.
1.96. Here?
1.645.
1.645. And here, the ladies? In my entire history of teaching, the ladies usually outperform the guys. This is the first of its kind where I've seen guys being more proactive. Okay, gentlemen, continue.
2.58.
Okay, so how are you finding that?
2.58 then?
2.33.
2.33.
2.33. For now, memorize. As I'm calling it a song.
So how do you find that? Like the 2.58 and 2. What are you doing to find that?
We learned that there are 3 steps, 4 steps involved, guys. What's the first step? For instance, for 95%, what's the first step you do? Guys? She's asking, how did you find 1.96 here? What do you do? Step 1, you find the level of significance.
The level, yes, which is 5%.
Then
we divide it by
2.
2.
This is a 2-tailed test, right? You get what?
2.5. Then I subtract from 100.
You subtract from 100 to get what?
97.
97.5.
0.5.
Then
we convert it into a decimal
which is
and we check 0.975. Then we go to our Z table to look for that figure.
And you go to our Z table and that figure. So in here, 0.975. Where is it? It's here. So this reading, you just add the number this side, 1.9 and 0.06, which will give you 1.96. So at that note, the ladies will lead us through how do we find the Z if we're given something which is not here, like 97%. What do you do? Step 1, ladies. You find the level of significance for 97%, which is what? Guys, help them. What's the level of significance at 97%? The difference from 100%.
The difference of 100, which is 3.
Then
We divide it by 2.
which is what?
1.5.
Then
1.5.
Then we subtract from 100.
which is
98.5.
then convert to decimal, which is 0.9850. Then you check it from inside the table. Which one is close? Oh, exact. We have 98.50, which is 2 point what? What is the reading for this, ladies? What's the reading? What's the Z for this?
0.9850.
Yes, this is a probability, but what is the Z at this point?
2.1.
2.1 what?
2.17.
Yes, 2.17. 2.1, then you add. Yes. Okay. So this is how we do the reading, 2.17.
So, Colin, sorry.
Mhm.
How do we know when to read outside or inside the table?
Whenever we are asked to read from outside the table and inside the table, when you're finding the Z, we're reading from inside the table. When you're finding the probability, you're reading from outside the table. In short.
Okay, thanks.
So now this is where, but these are the common ones. So what we're saying is you need to master this song. The top two are twos. So 99 is 2.58, 98 is 2.33, 95, 1.96, and 90, 1.645. Ladies, if you're able to remember the shade that man wore when he was appointing you and the shoes with terrible exactness, redirect your efforts to memorizing this because it will come. Also, if you're not given a confidence level, the standard is 5% or 95%. Is that clear? So when you read this, our Z was 1.96. All right. So we're still looking at this question here. Our confidence interval, 95%, that's where the 1.96 is coming from. This is the most common one. So we have been asked to find the mean. Who remembers how do you find the mean when you're given the confidence interval? What is the mean? X bar?
We add the 2 and divide by 2.
Lower bound plus upper bound divided by 2. What do we get?
We have 178.2. 78.2.
Divided by what?
No, I've already divided by 2.
As a final answer, okay.
Yes.
Then what is our error?
Our error will minus the lower from the upper and divide by 2.
What do we get?
.98. I think negative 0.98.
Our error is plus minus any of them, yeah? Sometimes it can be upper bound minus lower bound. It's the same thing. So we found the mean. Cannot find the standard deviation before finding what? The error. So we've been asked to calculate the confidence interval at 98%. So at 98%, we need to first know what the standard deviation is. So n is equal to what? Z squared over E squared. Are we given the n?
Yes.
It's 100, right?
Yes.
The Z, 1.96.
1.96.
Standard deviation,
Not given.
we don't know. Then, so cross multiply. Calculate the value of variance and standard deviation. So when you compute this, you find exactly the variance as 25 and the standard deviation as 5. And now we've been asked to calculate a 98% confidence interval. Can somebody tell me at 98%, what is our Z?
2.33.
2.33. What's the formula for confidence interval? Confidence interval is what? X bar plus minus Z over root of n. So we already calculated our mean as 178.2. Our standard deviation 5. Our Z 2.33. So 178.2 plus or minus 2.33. Then here we have 5, and the n was 100. 100 remaining purpose. And you're able to calculate confidence interval. Is that clear? So what are we having here? We're going to have our mean was 172. We calculate our standard deviation would be 5. Then to calculate the confidence interval, we have this. So I've combined two important topics in one, so you needed to really take your time to understanding this. A random sample of 64 sweets is selected. Already our n is what? 64.
64.
And we're using Z whenever the sample size is what? Greater than
Above
Z.
8.
And this, the seeds are found to have a mean mass of 9.0932. So these are X bar. And the standard deviation is 0.1. These are standard deviation. Determine a 99% confidence interval. So our Z at 99 is what? 2.58.
2.58.
Okay.
Yes.
So we know the formula is X bar plus minus what? Z
Z
standard deviation over root of what? N.
and
So this is our mean, 3.32. Our Z is 2.58 and our N 64. So you're going to get the confidence interval as follows. Is it making sense?
Yes.
All right.
Yes.
So I'll teach you how to use the T distribution. Sometimes we'll be given an array of numbers. Here we use a T table, which I will teach you tomorrow. For now, I just want you to understand the Z table itself. So let me now go to an exam type of a question. Like I said, now that we have gone through what is involved, please don't embarrass me. So we're going to apply all the principles we've just looked at now. On confidence interval, then we go to a two sample. So sometimes we're given two samples. The formula for confidence interval for two samples is x1 minus x2 plus or minus z. Then we have plus s2. So this is how we find confidence interval for two samples. So for instance, We have A and B. Here we have the mean, sample size. If our mean 1 was 10, and the mean B was 5. Here we have 36, and maybe here 30. And we have standard deviation, 10, and say 6, and here we have 4. Our alpha is 0.02. So using this formula, just put confidence interval is equal to mean 1, and mean 1 is what? 10, minus our mean 2 is what? 5. Our Z will be at 0.02, which is 2%, we're going to have 2.33. And standard deviation for sample 1 is what? 6 squared over 36 plus 4 squared over what? Sample size, which is 30. Here, the difference in the mean is 5 plus minus 2.33. And what we get in the square root here? What are we getting the square root?
One 1.238.
1.238.
1 point. The square root is already
Yes.
238. Then you multiply these two. Multiply these two, what are you getting?
Two point 885.
2.885. What is our lower bound?
Uh, 2.115.
The upper bound?
Seven.
885. So an exam type of a question would come like this. We have well-nourished and undernourished children. So the number of children here is what? 95, and here is 75. The mean is what? 11.2 and 9.8. The standard deviation is 0.9 and 1.2. We are asked to calculate a 95% confidence interval, mu1 minus mu2. This is 10 marks. Can you fail to answer this question? Do we need to answer it or we just explain the principles? So confidence interval is equal to what? Mean 1 minus mean 2. Our first mean 11.2 minus 9.8 plus minus, what is our Z?
Our Z is 1.96.
1.96. 96. Good. Then square root of S1 is what? 0.9 squared over its respective n, which is 95.
95.
Plus S2 is what?
1.2 squared.
1.2 squared over its
75.
respective n, 75. And the rest you can manage to do. Sometimes you'll be given a conclusive table like this. Not to summarize, but in a certain city, the average homes in 2000 were 148. In 202, the average price of homes was 155. So there's mean one and the mean two. Suppose means were based on a random sample of 100 homes in 1997 and 150 in 1998. So this is sample N1 and N2. That the sample deviations or prices were 21 for 2000 and 23 for 201. So this is S1 and S2. Find a 98% confidence interval for the difference. So you get a picture, right? You can summarize this in the table like this. Are we together?
Yes. Yes, we are.
Yeah, interesting, isn't it?
It is interesting.
Yes.
Okay. So this is how confidence interval is supposed to be done. Now, when we're dealing with proportions, however, sometimes you're not given sample sizes. You just be given capital N, A, and B. We have small sample and big sample. Maybe here we have 30 out of 50. And here we have 20 out of 40. So you need to know that the sub-proportion is a small population over a big population. So 0.3 over 0.5 of 30 over 50 is 0. What? It's 0.6, meaning the remainder is 0.4. Here, it's half, 0.5 over 0.5 as Q. So our confidence interval is equal to, for two proportions, P1 minus P2 plus minus Z, P1, Q1 over its n plus P2, Q2 over its n. So our first proportion is 60%, which is 0.6, minus the second proportion is 0.5. And if you're not given a Z here, the standard is what? 5%, which is 1.96. Then our P1 is 0.6 and our Q1 is 0.4 over the big sample size N, not small sample size, the population size. So here is over 50 plus PQ here is 0.5 over the sample size, the bigger one is 40. Then the rest is just a mathematical draw. Any questions this far? So we sometimes given questions that have two proportions. and you need to calculate the P. Most people fail to understand how to calculate P. It's simply the difference between the two sample sizes. You calculate the bigger N, you divide it into the small n. Okay, so I will now do my last question, then we can end there. And I'll give you some homework based on what we have covered today. Any question before I go there? Or any question to do with that topic on estimation, I can answer as long as there's nothing to do with T. This question inevitably comes with what? Hypothesis testing. So you can't specialize in a question. Say I'm going to do hypothesis testing. But here's a question. A random sample with standard deviation 4 and a 9% confidence interval with the mean was 19.7274 and 20.726. What is the mean and what is sample size? 10 max. This was in an exam. So what we're going to do is the word wire. So somebody should answer something and you can be free to go. Okay, this one I've already done. So let's participate. What are we given and what are we looking for? This was 10 marks. Let's go. A random variable has standard deviation of 4 and 9% confidence interval for a mean of the variables that and that. What is the sample mean and what is the sample size? So what are we looking for here? Please at least say something. What are we given or what are we looking for?
The mean.
Huh? So say something starting from Maggie, Daphne, D, Evans, Kabwe, and Joseph. And
The mean.
Please, and then coach more. Error to the easy. So we're looking for the mean. I need somebody to say something. Next.
Standard deviation.
We're given a standard deviation of what?
4.
Somebody else?
Confidence interval.
What is the confidence interval we're given?
Lower bound is 19.274 and upper bound is 20.726.
Next. What else are we given? What is our Z?
The Z is 2.58.
Wow, who was that?
That was Daphne.
Ah, great. That's good. How did you get it from the 99%?
You asked us to memorize, but I know how to get it.
Ah, okay, cool. So now, anyone else, how do we find the mean? So we're starting with the mean. Somebody else?
For the mean,
Maggie, I need to hear. How do you find the mean?
We have the lower bound and the upper bound divided by 2.
Good. Lower bound plus upper bound divided by 2. What is our lower bound?
19.274.
And yeah. So somebody else calculate, please. Anyone else who should find the mean? They've already given you the formula. Quickly.
The answer is 20.
Answer is 20. All right. Then we've been asked to find what? The sample size. But the sample size needs what? An error. So we need to know what the error is. Who should handle it for error? Pangashan, this formula. Anyone who hasn't spoken? Yes? Error?
So error is equal to the lower bound
Mm-hmm.
minus the upper bound
Mm-hmm.
divided by 2.
Which is what? What is the error?
-0.776.
Negative 0.7.
0.776, okay? And now all of you calculate the sample size. Don't say it, just post it in the chat. That order quickly.